This is the typical CNC lathe. Here is the control from panel, and then this is the cover of the CNC lathe. And the stiffness of the CNC lathe or any machine tool will be very important because it will not only affect the machining accuracy, but will also cause some machining stability problem. This is a turret which can hold many tool holders. And this is the dynamometer which can measure the cutting force or different kind of loading force in 3 directions. The purpose of this experiment is to estimate the stiffness of this machine tool. And it is measured by knowing the deflection of the cutting tool under some loading force. Here is a different angle to look at a cutting tool. In order to measure the deflection of the cutting tool, we put 3 capacity sensors in 3 different directions. This sensor is to measure the cutting tool deflection in the radial direction, is to measure the deflection in the feed direction. And the third sensor here, as you can see here, is to measure deflection in the cutting direction. And here, we also have a dynamometer to measure the loading force in 3 different directions. That is, the radial direction, the feed direction, and the cutting direction. This way, we can measure all the signals we need to determine the stiffness matrix of the machine tool. This robot arm is used to hold all the 3 sensors we use for deflection measurement. Then, let's look at the amplifiers we need. These 3 charge amplifiers is to transduce the force signal measured from the dynamometer into a data acquisition system. It's here. And we use a 286 IBM computer to perform as a data acquisition system. And for this amplifier is used to transduce the deflection signal from the capacity sensor and then put it into the data acquisition system. Now we are going to put some loading force on the cutting tool. This is a special device for us to put on the load by hand. Now I'm going to put on some load in the feed direction on the insert. This is the insert. Let's point now. Now if I bend this bar a little bit, I'm putting some load on the insert. This way we can measure the loading force and the deflection under the load. And similarly, now I'm going to put on the load in the cutting direction. Now, when I bend this part, we can measure some loading force here and also measure the deflection under the load. And similarly, we can perform the loading condition in the X direction. And then this way, we can measure all the signal we want and calculate the stiffness of this machine tool. Well, now we can see the measure result from the screen. We have 6 channels, 3 channels for the deflection signal, 3 channels for the loading force signal. And for each row, that means the measurement for each experiment. So this way we can have the results of many experiments, and then we will use these results to calculate the stiffness matrix of this machine tool.